So today we're talking about naming and writing formulas for acids and bases. And this is the last set of notes on naming compounds and writing formulas for compounds. So a quick little review of acids. Acids produce hydronium ion. And the reason this is important and the way that it does is that it gives a hydrogen to water to make this hydronium. So according to this definition, if you're going to give something, then that means that you have to have it. And that's going to be the key in identifying on whether or not you have an acid or not. One of the biggest challenges for this test is when I give you a compound, you have to figure out, is it ionic, is it covalent, and now, is it an acid? And so there's certain signs that we're looking for, and the biggest one here is that it has hydrogen in it. More importantly, we're going to see is that it starts with hydrogen because it has to have it in order to give it. So here we can see the example that it has this hydrogen. This is why it's an acid, is because it has the hydrogen. It comes over, gives it to the water. Hydronium, magic. No, chemistry. So how do we name these compounds? So there are two types of acids. This little box down here is on your chemistry help sheet, which you will obviously have access to on the test. And the two types are the types with oxygen and the types without oxygen. And depending upon which type it is, we have a different naming process. So let's look at the ones without oxygen first. First off, they start with hydrogen. That's how we know it's an acid. And then we look at the formula, and there is no capital O, so it doesn't have oxygen. So to name this, it's a fill-in-the-blank type of process. It's a hydro blank ic acid. So what goes in the blank? Whatever that other thing is without the last syllable. Okay, let's look at an example. So here we have HBr. So right off, I know it's an acid because it starts with hydrogen. Next, I look at the Br. There's no capital O, so I know that there's no oxygen. So I'm using my formula, hydro blank ic acid. It's bromine, so I chop off the last part, and I just plug it into the blank, and I get hydrobromic acid. If it does have oxygen, so again, it starts with H. This is how I know it's an acid. And since I do see the capital O, I now have other things to consider. To name this compound, I have to know what is that other thing. And typically, these are always going to be polyatomic ions like sulfate, phosphate, nitrate, or sulfite, or chlorite, or any of those other types of things. Those are the anions, the negative ions that have oxygen in them. So that's what I'm paying attention to, and that is what's going to dictate the name. Notice it doesn't start with hydro. It's just blank ending for the acid. So here, in this example, I see that it starts with hydrogen, so I know it's an acid. And then SO4, that's the other thing. I look on my pink sheet, what is SO4? I notice it's the sulfate ion. And so what's my rule? Well, if it ends in 8, go away, little thing at the bottom. If it ends in 8, then I just replace the 8 with an ic acid. So sulfate, this becomes sulfuric acid. So I can see the ic acid is because it's an 8 ion. And again, there is no hydro in front of this. If I look at this example, again, H starts with H, so I know it's an acid. SO3, I look on my pink sheet, it's sulfite. What's my rule? Well, if it's an ite ion, then I change the ite to an OUS acid. So sulfite becomes sulfurous acid. So I can see this OUS acid. OUS is because it's sulfite. And again, there is no hydro in front. Okay. So go ahead and pause the video and try to do these 4 examples on your own. Great. Let's look at the answers. So there is no oxygen here, so this is why it starts with hydro. This is chlorine, so I get chloric acid. This is nitric acid, because this is nitrate. 8's become ic. There's oxygen, so that's why there's no hydro, like in the previous example. Hydrosulfuric acid. And the last example, PO3. It has O. This is phosphite, so this becomes phosphorus, OUS acid. Now, how do we write the formulas? Writing formulas for acids are nothing special. The way that we write them is the same way that we write formulas for ionic compounds. Except here, we know because it's an acid that the positive ion is H with a +1 charge. So really, it's just what is that negative ion, what is that anion and the charge, and then we just crisscross. Or we balance out the charges till they equal 0. So a couple things to know, that if it starts with hydro, then you know there's not going to be any oxygen. And if it doesn't have hydro, then we're looking for those polyatomic ions, the sulfates, the nitrates, or the chlorides, or the hypochlorites, whatever the case may be, to figure out what anion it is. Because once we know what the ions are and their charges are, then it's just what we've been doing with ionic compounds. So let's look at an example. Here it's hydrofluoric acid. So it's an acid, so I know that it's +1. So then what's the other thing? Here, because it's hydro, I'm only paying attention to that blank spot, that fluor. So I know that this is fluorine, or fluoride if you look on the pink sheet. This is +1, this is -1, the charges cancel, so I get a formula of HF. Let's look at an oxygen containing. So there's no hydro. Well, first I know it's an acid, so I know that I have hydrogen. But since there's no hydro, then this ic is supposed to be 8. So what I'm looking for in the pink sheet is carbonate, which is CO3 with a -2 charge. Once I know the anions, I can balance out the charges, or I can simply just crisscross, and this 2 of the carbonate tells me that I have 2 hydrogens for every 1 carbonate, and this is what I get for my formula. One last example before we do some practice problems, nitrous acid. So again, it's an acid, so I know that it's H+1. And then nitrous, so this OUS, there's no hydro, so I know the OUS turns into ite. So I'm looking for nitrite in my pink sheet, which is NO2 with a -1 charge. Once I know my ions, I can crisscross, or I can balance the charges. The charges are already balanced, so it's just HNO2. Okay. So again, let's practice some. So go ahead, pause the video, and try to do these 4. So let's look at the answers. So here's what we have for our answers. Again, when it's hydro, I know that there's no oxygen.
In the 11th grade with the last name beginning with the letter F, please go to the activity center to get your pictures taken.
You've already gotten your pictures taken. And then the other ones are all of these ics turn in. Perchloric was perchlorate. Phosphoric is phosphate. Carbonous is carbonite. And so hopefully you're noticing these polyatomic ions match up on the pink sheet. Bases. Bases are nothing special. Bases produce hydroxide, just as a review. But about naming and writing formulas, these are just ionic compounds. There is nothing special about bases other than we just call them bases. But in terms of naming them, in terms of writing their formulas, we just follow the ionic rules. The only thing difference is that hydroxide is typically always going to be their anion. Okay, so how would we name this if it was an ionic compound? This is sodium. Well, what's OH? It's hydroxide. There's my name, sodium hydroxide. So here's some examples of formulas and name, and here's some names and write the formulas. So go ahead, pause the video, and try these examples. Let's look at the answers. This first one is calcium hydroxide. K is potassium, so this is potassium hydroxide. Sr is strontium, so this is strontium hydroxide. Copper 2, this 2 is my charge, so that's why I need parentheses around the hydroxide because I have 2 of them. And then magnesium hydroxide, magnesium is also +2, so I need parentheses around my hydroxide. And that's it.